Today we'll be constructing perpendiculars to a line from a point not on a line. We can also do it from a point that's already on the line. We may practice that as well. So I want you to notice what's going on in stage 1 and stage 2 of the construction. I meant to grab a highlighter there. So stage 1 and stage 2 of the construction. Step 1, you can see that they've drawn a line and a point labeled P that's not on the line. Step 2, let's look at what's going on. It looks like they have an arc that was the same distance from P to B as P to A. So they swung this arc. This is just a sketch, but as we're planning ahead, we can tell what they've done. So let's go ahead and practice that. I'm going to start by drawing a line. Let's scoot this over a little bit. I'm just going to draw a line and move this out of the way. Draw a point not on the line. Like the example, I will call that P. I'm going to open my compass so that the point is on P, and the pencil is just a little past P. So when I make that arc, I want to intersect it twice. So I'll intersect it there and here. And now I've got 2 points, and I'm going to call them B and A, like the example. So now I have a segment AB and a point P, and I want to draw a perpendicular bisector of AB. So since I already have point P that I know falls on that line, I can open my compass to any measurement that I want, as long as it's going to fit on my paper here, and they'll overlap. So I'm going to make one arc from A, and I'm going to turn my compass, same compass opening, and I will make another arc that intersects the first arc. When I go back to my straight edge, I will connect point P with the point of intersection. And when I measure here with my protractor, it should be an exact right angle. Just adjust it just a little bit. Pretty close. So I've got a perpendicular from point P to line AB, and there's my perpendicular line. Right below there, why don't you pause this and go ahead and practice one more. So again, to construct the perpendicular to a line from a point not on a line, I've got my line, I've got a point, I'm going to label it P. Open my compass a little past the line, that should be enough. Make an arc. Oops. That intersects the line twice. Use those 2 points to make an arc. They don't have to be labeled. I will label mine so I can talk about, but really you just find those points of intersection, and I will connect point P with the point of intersection. And it should look like a nice right angle. Again, you could put your corner of your paper in there just to check. All right, so as in our example, this was point B, and this is point A. And as the problem suggests, randomly place points on AB as Q, R, and S. So put a Q somewhere, put an R somewhere, you can put it here. And let's put an S somewhere. And let's call the point where the line with P on it intersects AB as M. And with your ruler, or even with your paper, you can measure and notice which one is the shortest. So the question is, which of these are shorter? From P to M, P to B, P to S, any of the points on there, P to R, P to A, or P to Q. And by measuring, you can measure again with your ruler if you want, or you can use your compass to measure it. You will realize, or you should realize, that the shortest distance is from P to M because it's on that perpendicular. And so hopefully that makes sense to you, and we can fill that in. So the shortest distance from a point to a line is measured along the perpendicular from the point to the line. So in that blank, put perpendicular. And up here you'll see the book's example of kind of the same idea. You can see that from P to M, since it's the perpendicular, that has to be the shortest, and it's the only one that kind of makes sense here. If you think about constructing perpendiculars from a point to a line, imagine if you were in a room and you look over to one of the walls. Maybe you're sitting here. You're sitting here and the wall is here. If you had to measure the distance from the point to the wall, this is my wall, and this is you, how would you measure it? So you can see there's a lot of different measurements you could make. Maybe the door is here, and you could say, well, it's this far to the door. Or maybe the window's here, and it's this far to the window. But in geometry, when we talk about the distance from a point to a line, we always want that perpendicular distance. So everyone should get that same measurement. Whatever that point is, we find the perpendicular, and we're able to measure that distance. So to fill in some of those blanks, the distance from a point to a line when we are in geometry, we say it's the length of the perpendicular segment from the point to the line. And as a review, we need to know the altitude of a triangle. So it kind of has to do with that. We'll be constructing some of these. So the altitude would be the perpendicular segment from a vertex to the opposite side, or a line containing the opposite side. So if you look at the drawings here, I'll grab up my highlighter. An altitude we think of as height, but it doesn't always have to go vertical. So if this is the perpendicular from the vertex to the opposite side, then that would be an altitude. So it's altitude from this particular base. If we wanted the perpendicular from this point to this side, we'd have to extend the side out to find the perpendicular, which would be the altitude. And then if we had a right triangle, it's really convenient just to use these as the legs as the altitudes, because it does go from a vertex to the opposite side. So there's that one, and then this vertex to that opposite side. So as long as the altitude is perpendicular to the opposite side, you've got the right thing. So let's draw a triangle and construct an altitude. Remember, drawing is when you use your construction, or you use your geometry tool. So you could use your ruler and measure it. Doesn't have to be any particular size. So I'm just going to use a straight edge just to draw any old triangle, just connecting sides. There's my triangle. I want to draw the altitude, so here's my plan. My triangle kind of looks like this. I want to be able to find this perpendicular to the side that I'm going to call kind of the bottom here. So this is a plan. A lot of times with constructions, if you have a plan, it's going to help you to think things through before you do so much work. So I want a perpendicular, again, from this vertex down to this side down here. I'm going to do a similar construction to what I just did. So like this is my point. It's a little bit smaller. There's my point not on a line. So we can make it bigger. And here's the line. So I'm going to extend this out so it's a little bit further than the line, and I'm going to make an arc. And I'll get a different color. So there's my arc. If I don't have an intersection here, I can extend my line a little bit further by using my straight edge. So if you ever have that happens to you, just extend your line. So I see a point of intersection right here and a point right here. So similar to the last construction that we just did, a perpendicular to a point, or to a line from a point on a line. I'm going to use those 2 points. find another point of intersection, and now I can use my straight edge and connect this vertex here with my point of intersection, and I should have a nice right angle here. Again, you can measure that with your protractor, or just put the corner of your paper in there.